Piping systems are a vital part of most industrial facilities, and valves are a vital part of those piping systems. Valves regulate the flow of liquids and gases through plant systems. Like many other system components, valves need to undergo regular maintenance to help ensure that they're kept in good repair. Before any kind of maintenance is performed on a valve, certain preparations should be made. In addition to getting permission from a supervisor and following your plant's procedures and safety precautions, there are some basic preparations for valve maintenance that are common to most facilities. Once a valve has been identified as requiring maintenance, either through a routine inspection or because a problem has been reported, a good first step is to check the valve manufacturer's instruction manual. This will help you become familiar with the valve's internal design specifications and will also alert you to any special maintenance instructions for that valve. Part numbers and other information can also be found in the manufacturer's instruction manual. If you know that replacement parts are needed, consult the manual and order them ahead of time so that they're available when maintenance begins. When you're ready to start work on the valve, gather all the necessary tools for the job, including hand tools, measuring tools, cleaning tools, and any special tools suggested by the valve manufacturer. Inspect each tool carefully to make sure that it's in good condition. Additionally, you'll need to prepare the work area. Remove any objects that might obstruct maintenance or create a safety hazard. The valve must be taken out of service before it can be worked on. For some valve maintenance jobs, the system that the valve is part of must be taken out of service. In other cases, it may be possible to bypass the valve and still keep the system in service. In any case, the valve should be locked out and tagged in accordance with your facility's procedures before any work is done on it. Likewise, all pressure must be relieved from the valve and all fluid must be drained. The mechanic has made all of the necessary preparations and the valve has been taken out of service. Now let's see how he removes the valve from the system so that he can take it to a shop for repairs. Valve removal procedures may differ depending on how the valve is attached to the system. In our example, the mechanic will remove a globe valve that is connected to the system by flanges. The mechanic sprays each flange bolt with a penetrating lubricant and then loosens the bolts on the side opposite from where he is standing. This helps the mechanic avoid injury by releasing any trapped pressure away from him. Loosening the flange bolts may also result in a small amount of fluid leaking out from between the flanges. This is normal, and it can occur even when the pipeline has been drained. The bolts are loose and can now be removed. The mechanic takes them out one at a time until only one bolt remains in the flanges at each end of the valve. The two bolts that the mechanic leaves in place are diagonally across from each other to provide maximum support. If the valve is large, rigging or other types of support should be used. If necessary, rigging should be attached before the valve is free. Personnel can be injured and the seating surfaces of the valve and the flange can be damaged if the valve crashes to the floor. Before these last two bolts are removed, the valve must be supported by some other means. If the valve is small, another maintenance worker can hold the valve in place while the last two bolts are removed. This valve is large, so rigging is necessary. The mechanic can now remove the old flange gaskets. Anytime a flange is taken apart, the gaskets should be replaced. The mechanic stores all removable parts, such as nuts and bolts, together in a safe place so that they are readily available when they're needed for reinstallation. Finally, with the valve properly supported, he carefully lifts it out. As with any plant component, valves are susceptible to problems. One of the most common valve problems that maintenance personnel encounter is excessive packing gland leakage. In order to properly control valve leakage, maintenance personnel should be familiar with the construction and use of packing. In this part, we'll see how to adjust, remove, and replace packing. The packing used in valves is typically a rope-like material made from strong natural or synthetic fibers woven together with a binder substance, such as grease or wax. It's used to control leakage around the valve stem. Packing is housed in an assembly called a packing gland. The packing fits around the valve stem and fills a cavity called a stuffing box. A device called a gland follower fits into the stuffing box to compress the packing. When the valve is fully assembled, the gland follower is tightened to exert pressure on the packing and hold the packing in place. Let's watch as this mechanic adjusts the packing in a globe valve. He compresses the packing by alternately tightening the gland nuts in a clockwise direction. This causes the gland follower to push against the packing, compressing it. To ensure even compression, he tightens each gland nut one flat at a time. A flat is equal to about 1/6 of a full revolution. A ruler can be used to check the gland follower for even compression. To do this, measure the distance from the top of the packing gland to the bottom of the gland follower. If the gland follower has been tightened correctly, the measurements should be the same at both gland bolts. The packing should be compressed enough to prevent leakage, but not enough to prevent movement of the stem. After the packing is adjusted, rotate the hand wheel open and closed to make sure that the stem can still move freely. As the packing is adjusted over time, the gland follower may eventually be tightened so much that it comes to rest on the bonnet. If this occurs, the gland follower is bottomed and cannot be tightened any further. When this happens, the packing should be removed and replaced. Worn or damaged packing must also be replaced. Let's look at an example of how to remove valve packing. Most valves are designed so that the packing can be replaced without having to disassemble the entire valve. In some cases, it may be necessary to remove the valve's hand wheel to gain access to the packing gland. With larger valves like this one, the hand wheel may not have to be removed when the valve is repacked. The mechanic sprays a penetrating lubricant on the bolts to make the gland nuts easier to remove. If the nuts are rusty and won't move, the lubricant should be given a few minutes to work. Using excessive force may twist or break the bolts. Now the mechanic turns the gland nuts counterclockwise to loosen and remove them. He stores all the parts together in a safe place. After the gland nuts are removed, the mechanic raises the gland follower. On this valve, the gland follower cannot be completely taken off while the stem is still in place and surrounded by packing. Instead, it's held out of the way with a wire. Keeping the sharp end of the packing hook clear of the valve stem, the mechanic removes the rings of packing one at a time. This step is done carefully because scratching the stem with the packing hook could cause liquid to leak past the packing when the valve is put back in service. A scratched valve stem could also damage the packing as the stem turns. The number of rings, the packing type, and the packing design will all vary from valve to valve. A die and tap are normally used to make new threads, but they can also be used for chasing or cleaning threads. When they're used for chasing, the die is threaded onto the bolt and the tap is threaded into the nuts. The die and tap must be correctly threaded on the bolt and nut threads. This avoids cross-threading or cutting new threads, which will destroy the original threads. The die and tap should be the same thread size and type as the bolt and nut. To chase the threads on a bolt, spray the bolt with a lubricant and thread the die onto it. Then move the die back and forth to clear the threads. Back the die off and remove it when the chasing is completed. To chase the threads on the nut, spray the nut with a lubricant and thread the tap into it. Repeat the same process that's used to chase the bolt. Chasing refurbishes threads by removing rust and other chemical deposits that a wire brush cannot. It also smooths the threads. Now the stuffing box is ready to be filled with new packing. The packing that's used must be compatible with the valve and the fluid that flows through the valve as well as with other materials in the system. To accommodate a variety of systems and valves, many different types of packing are available. To determine what diameter of packing is needed, measure from the edge of the stuffing box opening to the stem. For this valve, we'll need packing with a diameter of 5/16 of an inch. Some packing is available in bulk form on a spool or roll that can be cut to any length. To cut packing from a spool, wrap a portion of the packing around the valve stem once to form a ring. Then use a utility knife to make a cut mark where the end of the packing overlaps itself. Place the measured packing on a wood block or table and cut it all the way through with the knife. One type of cut is a straight cut, which is made perpendicular to the stem. This is known as a butt cut, since the ends of the packing will butt together where they meet. Another basic type of cut that can be made is a miter cut. For a miter cut, the packing is cut at a 45-degree angle to the stem. Do not wrap the packing around the valve stem to cut it. This could damage the stem and ultimately cause leakage. Instead, to make a miter cut, wrap the packing around a mandrel. A mandrel can be an old pipe or other piece of round stock that's approximately the same diameter as the valve stem. The type of cut made will depend on the pressure the packing must retain. Though a miter cut is more difficult to make correctly, it generally holds more pressure. There are other specialized cuts, but the butt cut and the miter cut are the two most commonly used when packing is cut from a spool. After the first ring of packing is cut, stretch it out straight and mark its length on the wood with the knife. Then additional rings of packing can be measured against the marks and cut to match the length of the first ring. This method is not always effective for larger valves with thick packing. Often a small V-groove is formed at the adjoining ends because the packing isn't curved when it's cut. The V-groove would allow packing leakage. To avoid the V-groove problem on larger valves, wrap the packing around a mandrel and then cut it. Pre-formed packing is packaged in various pre-cut sizes, ready to fit into a stuffing box. If a valve requires packing to be arranged in a particular order, the pre-cut packing is typically packaged in that order. As a result of damage in manufacturing, transit, or storage, pre-cut packing may sometimes be broken or cracked. So be sure to examine all pre-cut packing carefully before using it. Besides the pre-formed type, some packing comes in loose or granulated form. Loose packing is poured into the stuffing box and will take the shape of the box. It requires repeated compression with the gland follower in order to completely fill the stuffing box. Some packing is impregnated with special lubricants. The lubricant makes the valve stem rotate easier, resulting in less wear on the packing. Once the proper packing has been selected and prepared, the valve can be packed. The mechanic shapes the first piece of packing into a ring and carefully fits it around the stem, making sure that the ends meet securely. Now he presses the packing ring into the stuffing box until it's inside all around. Then he uses the gland follower to seat the packing ring. If the packing ring is not properly seated, it will not seal properly and the valve may leak. On many valves, the gland follower is not long enough to adequately compress the packing as it's installed. In such cases, a tool called a split bushing or split ring packing compressor is often used. The split bushing is typically constructed from wood or soft metal. In order to fit into the stuffing box, it is slightly smaller than the stuffing box. The mechanic installs the remaining rings of packing in the same way as the first ring, always making sure that the ends of each ring meet. If there's a gap between the ends of the rings, leakage through the packing could result when the valve is put back in service. To make it more difficult for a leak to occur, the point where the ends of one ring join should not align with that point for any other ring of packing. This type of alignment can create a path for leakage through the packing. The mechanic in our example is careful not to overpack the valve by putting too many packing rings into the stuffing box. The valve manufacturer's instructions usually indicate the correct number of rings that should be used. After all the rings of packing have been installed, the mechanic puts the gland follower over the stem and presses it into place. Next, he manually screws down the gland nuts until they are finger tight. The mechanic uses a wrench to finish tightening the nuts. He tightens the nuts evenly by alternately turning each nut one flat at a time. After the valve has been repacked and reassembled, the mechanic cycles it open and closed several times to properly seat the packing and to make sure the valve moves smoothly. Before a valve can undergo any type of maintenance, several things must happen. For example, maintenance preparations have to be made, and the valve must be removed from service. If appropriate, the valve may also be removed from its system and taken to a shop for repairs. Then the valve is disassembled and its parts are inspected. In this part, we'll look at a typical disassembly procedure for one common type of valve, called a globe valve, and we'll see how to perform a valve inspection. To disassemble this globe valve, the mechanic in our example first loosens the bonnet nuts and the gland nuts on both sides. Next, the mechanic unscrews the gland nuts completely and removes them. This relieves pressure on the packing. Now he removes the bonnet nuts and the bonnet assembly and removes the sealing gasket. To remove the hand wheel, he rotates it in the closed direction as far as possible and then removes the hand wheel nut and the hand wheel from the valve. Now he can rotate the valve stem until it's out of the bonnet. The mechanic extracts the gland nuts and bolts, and now that the stem is removed, takes the gland follower completely off. Finally, he pushes out the old packing. Once a valve is disassembled, its exposed parts can be inspected thoroughly. The mechanic in our example begins the inspection at the flanges. First, he cleans the flanges on the valve with the wire brush. He uses a gasket scraper for hard-to-remove material, being careful not to gouge the flange sealing surface. Then he checks the flanges for nicks and corrosion. Flanges that are in good condition will have a smooth surface. The stem bushing should be inspected for wear and damage as well. If the bushing threads were allowed to wear out on a rising stem valve, the valve would no longer open or close. Therefore, worn bushing should be replaced. The mechanic inspects the valve stem next for wear and damage. He starts by cleaning the stem with a fine emery or crocus cloth to remove dirt, chemical buildup, and burrs. Even properly adjusted packing can leak if the valve stem is bent or worn. A bent or worn stem can prevent the packing from sealing properly and make the valve hard to open or close. With the stem on V-blocks, the mechanic checks its straightness by using a dial indicator to perform a run-out test. He puts the dial indicator in contact with the stem, zeroes the dial indicator, and then rotates the stem. The stem is straight if the pointer on the dial remains constant on 0 during the entire rotation. Deviation on the dial indicates that the stem is bent and that it may need to be replaced. Check with the supervisor for the amount of acceptable deviation at your facility before you replace a bent stem. A damaged or corroded stem may also need to be replaced. The mechanic can remove moderate amounts of corrosion from the valve bonnet or body with a wire brush. Finally, he inspects the disc. The mechanic checks the disc-to-stem connection for proper movement by turning it manually. Then he inspects the disc for wear, damage, and corrosion. Minor wear or corrosion can be repaired by resurfacing or lapping the disc. In the event of cracks or excessive wear or damage, however, the disc should be replaced. Once maintenance preparations have been made and the valve has been disassembled and inspected, maintenance can begin. In this part, we'll look at some typical valve maintenance procedures, including lapping and spotting in. In our example, the mechanic has already disassembled the valve and removed the packing. The seating surface of this valve bonnet has a minor steam cut, which the mechanic can repair through lapping. Lapping is a resurfacing process that is accomplished by rubbing a valve part against another surface coated with a lapping compound. This smooths the valve part's surface. Flat valve surfaces, such as the surface of this bonnet, are generally rubbed against a metal lapping block coated with a lapping compound. To lap mating valve surfaces, such as the surfaces of this disc and seat, the disc is coated with a lapping compound, and then the disc and seat are rubbed against each other. Now let's see how the mechanic laps the surface of this damaged valve bonnet. To begin, he applies a small amount of lapping compound to a lapping block. To achieve a smooth surface, he starts with the coarse grade compound and gradually changes to finer grades as the surface is smoothed. The mechanic moves the bonnet through the lapping compound in a figure-8 motion, being careful not to exert excessive or uneven pressure on the bonnet. The weight of the bonnet should provide adequate pressure to smooth the surface. The mechanic frequently checks the bonnet's seating surface by wiping away the excess compound and inspecting the bonnet. He repeats the lapping process until the seating surface is smooth. After lapping the bonnet, the mechanic checks the disc and seat for proper seating. An improperly seated valve will leak. One method for checking the disc and seat for proper seating is called spotting in or bluing. The disc normally rotates freely on the stem. This gives the disc a self-seating feature and provides a good seal when the valve is closed. However, during spotting in, the disc must not be allowed to rotate. To prevent rotation, the mechanic positions shims between the stem and the disc. This holds the stem in place and keeps the disc from rotating on it. Once the movement of the disc on the stem has been blocked, the mechanic applies an even, thin coating of a bluing substance to the surface of the disc. Next, he carefully places the disc on the valve seat and rotates it 1/4 turn with a slight downward pressure. When the mechanic removes the disc from the valve and inspects the disc and the seat, he should see a thin, even, unbroken blue line on the seating areas if proper seating occurred. When he's finished inspecting the valve disc and seat, the mechanic wipes them clean of the bluing. Imperfections detected in the disc or seat during spotting in will require repairs or replacement. Many valves are equipped with replaceable parts, which make it more economical to replace discs and seats with severe imperfections than to repair them. Check with the supervisor on the policy at your facility. If minor disc or seat imperfections are found, they are often repaired by lapping. With shims in place to keep the disc from rotating on the stem, the mechanic applies a small amount of lapping compound to the disc. He then places the disc on the seat and moves it back and forth with a slight downward pressure. Occasionally, he moves the disc forward 1/4 turn to ensure even lapping. The mechanic frequently checks the disc seating surface by wiping away the excess compound and inspecting the disc and seat. He repeats the lapping process until the seating surfaces are smooth. When the lapping is complete, the disc and seat should be spotted in again to make sure that they're seating properly. Once all the necessary maintenance has been performed on a valve, the valve must be reassembled so that it can be returned to service. In this part, we'll see how a mechanic reassembles a flanged globe valve. The mechanic in our example begins the reassembly procedure by removing shims that were placed around the stem during a spotting in procedure. Next, he lubricates all moving and threaded valve parts. Be sure to check the manufacturer's instructions to determine which lubricant is right for the valve that you are servicing. After all the moving and threaded parts of the valve have been lubricated, the mechanic puts the stem partially through the bonnet. Then he slides the gland follower over the stem and replaces the gland nuts. Next, he threads the stem through the stem bushing and replaces the hand wheel nuts and bolts and the hand wheel. Now the mechanic can replace the gasket between the body and bonnet. He takes the new gasket and sets it on the body seating surface. At this point, the mechanic turns the hand wheel until the valve is in the fully open position. When a valve is being reassembled, it is vital that the valve be kept in the fully open position. This keeps the disc from being driven into the seat during reassembly, which could bend the stem or damage the seating surfaces and prevent the valve from opening. Now the mechanic places the stem, bonnet, and packing gland assembly on the valve body and replaces the bonnet bolts and tightens them evenly to compress the new gasket. The bonnet must rest squarely on the body of the valve as each bolt is torqued to its proper value, as indicated in the manufacturer's instruction manual. Using a cross-torque pattern, the mechanic tightens one bolt. Then he tightens the bolt opposite it. Next, he tightens a bolt next to the first bolt, and then tightens its opposite bolt. He continues the pattern until each bolt has been torqued to its proper value. After the bonnet is installed, the mechanic repacks the valve. Now the valve is fully reassembled and ready to be reinstalled. Reinstalling this flanged globe valve involves two basic steps: inserting new gaskets and replacing the flange bolts. This valve is large, so rigging holds it in place while the mechanic wire brushes, lubricates, and replaces the two bottom flange bolts on either side of the valve. The mechanic then adds two additional flange bolts on each side of the valve. These bolts will hold the new gaskets securely in the correct positions. With the support flange bolts in place, the mechanic slips the gaskets in between the valve flange and the pipe flange. Then he tightens each flange bolt until the valve is securely in place. He completes the reinstallation by cleaning the work area and returning all tools to their proper storage places. Locks and tags can now be safely removed and the valve can be returned to service.